Hello and welcome to the segment of topic 3, trigonometric functions and geometry in the IB Math Analysis and Approaches, both standard and higher level courses. Today, we're going to go through these videos. Just a brief introduction for those who are new. NHY Academy is an academy that I have come up with um, after completing my IB exams. Even before that, I remember I was at the beginning of May 23 that I was actually doing trigonometric functions when I first started NHY Academy. And, this topic is really important to me because um, this is a huge part of what's coming in the exam. And two, it will be a huge part of your life, especially in calculus. I'm in university right now, and in calculus 2, you're going to see it a lot. I've seen a lot of applications of trigonometric functions where you have to know trig functions by heart to, um, apply, the knowledge and understanding of this into calculus. Not even calculus, you're going to need it for other topics as well, especially if you're doing engineering. You're gonna need these. So trig functions, you have to know they're gonna be a huge part of your lives, um, unless you're doing like something else that doesn't have to do with math. So let's go through it. It's not hard. It may look hard, but it's not. So I like to start off with just going through what's coming on the formula booklet because that's what you're gonna open. Now, once again, this is part one. I'm gonna go over through, the baby steps, and then we're gonna move on to like we're gonna fit ourselves in the big shoes once we're done with this. So a couple of things that I want to go through in this formula booklet. So this is what you're gonna see a lot in the exam. So this is just a snapshot from the IB Math AA formula booklet. And when you open your formula booklet, that's what you're gonna get. So, tan theta is sine theta over cos theta. That is something you need to know. I also want to add this. What was it called? Uh, Actually, I'm not going to include this one right here. Not now. I'll include it later because this is HL, and part 1 I just want to focus on the SL, so I don't want to get this confused. Um, let's move here down to Pythagorean identity. So, cos squared theta plus sine squared theta is equal to 1. And I'm going to get back to this in a second, because it's really important, and I want to just explain to you how the Pythagorean identity came to be. How is cos squared theta plus sine squared theta equal to 1? Again, we know the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Nor, how is cos squared theta plus sine squared theta equal to 1? So I'm going to get back to this in a second. And then we move on to double angle identities. We know sine 2 theta is equal to 2 sine theta cos theta. And then we move down to the other ones, which is cos 2 theta is equal to cos squared theta minus sine squared theta equal to 2 cos squared theta minus 1 equals to 1 minus 2 sine squared theta. So, big stuff. But again, you got the formula booklet with you. No need to get worried. You're fine. Nothing's gonna go wrong. You got the formula booklet with you. No need to memorize these. So I'm gonna say here, no need to memorize. Because if you do, you're screwed. You're gonna probably focus on. You're probably gonna focus on. You're gonna do sciences like physics, chemistry, and stuff, and you're gonna have to remember the theory part of chem and physics, and then you have to remember this. Yuck. The less you remember, the better. And this is gonna be given to you. It's not gonna be like poof Harry Potter magic. So it's gonna be given to you. Um, It's gonna pop and leave. You're gonna open it, it's there, it's not gonna disappear. All right, so let me get to this actually here. We're gonna be doing an example, but before we do the example, I just want to go through this Pythagorean identity. So cos squared uh, theta. Oh hell no! What is happening? Oh no! There we go. Plus sine squared theta is equal to 1. So I'm gonna go draw a triangle here. I'm gonna draw a triangle and I'm gonna put the angle right here. I'm gonna label this A, B, and C. So we know cosine as your adjacent over the hypotenuse. So, this is the adjacent. This is the opposite. And, this is the hypotenuse right here. So let's go ahead. So we know that cosine is adjacent over hypotenuse. So we're going to take A over C. And because it's squared, I'm going to square this whole thing. And then we're going to have plus, and I'm going to disregard the theta for now. And we're going to have sine squared, actually no need to disregard. This is equal to this. And then we have sine squared theta, which is b over c. And again, we're going to square that once again. And then, well, what's it going to equal to? I'll actually write out the bottom. Save space. And simply this is going to be a squared over c squared plus b squared over c squared. So, Pythagorean theorem, this is where it comes in. A squared plus b squared. Well, okay, let me write it this way. What is it equal to? A squared plus b squared. It's equal to c squared. That's the Pythagorean theorem. So, I can go ahead and say c squared over c squared. Whoopsies. Now what am I going to get here? C squared over c squared? It's going to equal to 1. Then, red. What am I doing? Oh, God. There we go. That's where we get it. Cos squared theta plus sine squared theta is equal to 1. And it always applies. And then these guys, a squared over c squared goes to this cosine squared theta, and then the b squared over c squared is just going to be sine squared theta. Now, Noor, why are you telling us this? You are probably going to get a question. Again, it's a 10%-ish probability that you're going to get a question where it's going to say, prove that this is true. You're going to get questions like these. So I just wanted to cover this quickly. Completely disregarded this question. I'm going to go through this question now as an example of how we apply trig functions, right? So let's go ahead. I'm going to erase this. Let's move on to solving this. I don't need the triangle anymore. We're doing trig functions. We're not going to do basic geometry anymore. I'm going to have to find what the hypotenuse is, you know? So let's look at this example. We got 2 cos theta minus 1 is equal to 0 for the interval they gave us, which is 0 is less than or equal to x, which is less than or equal to 2 pi. So within this, I'm going to have to find what x is. And we're going to have more than one value of x, because if I draw a cosine curve, I'm probably going to get something. It's going to go down, it's going to come up, it's going to go down. And at somewhere here, it's going to be like 2 pi, So at this point, we're going to probably cross 0 like more than once. So we have 1 and 2. I definitely messed this up, didn't I? Yeah, oh, okay. So, it's gonna go down. Whoopsie doopsie, and then it's gonna stop right here. And then at this point right here, it's 2 pi, right? Now it's telling us add 0. So, hold on. The wrong 0. The 0. So, this is y is equal to 0. So we got 1 point and we got 2 points. So we're going to be having 2 points for x. So I need 2 values for x. Right? So, let me go through this question. Let's go with blue actually. We haven't done blue in a while. So, I'm going to write the equation here. No, not this blue. No. Yeah. Okay. So I got 2 cos theta minus 1 is equal to 0. So let's rearrange this to make it look nice. So 2 cos theta is equal to 1. So I'm going to divide this by 2, write a proper 2 nor. That's a 2 here. Cancels out, but whatever you do on one side, you got to do on the other. So then that becomes it. And then we know cosine theta. Okay, there's a mistake in this question. This is theta right here. This is x. You're definitely not going to get something like this. This is my mistake. I just realized that right now. Just pretend this is theta for now. Right? Or actually, let's take it to be, yeah, let's leave it theta. And that's theta right here. Let me erase that. I don't want to, yeah, you guys are probably confused right now. I am very sorry. Theta. Right? So, once we got this, now we need to, solve what value of theta will cosine cosine of theta equal 1 over 2. So that's where I need to do is equal to, so theta is equal to cosine inverse of 1 over 2. Now, remember this. I'm going to link it down in the description, but remember this. Sally can't remember special division. You probably don't know what I'm talking about. So go down right now in the description. I have done a video about 6, 7, 8 months ago where I've talked about how to solve stuff like this. Um, but simply, I'll just go ahead and do it because why not? I'll just erase this and I'll redraw it later. Because I need more space. So you're probably gonna forget this right now. Oh God. So 0, 30, 45, 60, 90. Right? So again, cosine 1 over 2. So I'm gonna focus on this bit right here. So 1 and then 2. Right? Um, so then that could be what's it called? So that's equal to 60 degrees. We know 60 times simply pi over 3. That's number 1, right? That's going to be number 1. And then we have, what's it called? And then that's 60 times pi over 180. and then that's pi over 3. So now we found our first point, but remember we would need to find 2 points. So let me get rid of this one right here. Yeah, I need more space. You know, I'm actually using PowerPoint, but you know, um, why not? And then we have pi over 3, so I might as well do, and remember this, you can just do 2 pi minus pi over 3 simply equal to 5 pi over 3. That should be correct. That should be correct. So now I'm going to erase these, and you know, I can't move it around. See, that's the disadvantage of using PowerPoint right here. So pi over 3 and then 5 pi over 3. So then, you know, theta is equal to pi over 3 minus, sorry, not minus, pi, theta is equal to pi over 3, comma, 5 pi over 3. And there we go. It does fall between the intervals. And if I draw the graph right here, it's going to be a very short one. So it's going to be whoopsie doopsie right around here. This is our interval. This is 0 and this is 2 pi. That's 1. That's 2. You know, and that's going to be 3 pi. No, that's going to be not 3 pi. Pi over 3. So that would be pi over 3. And then this one right here would be 5 pi over 3 for this point. Alright, sorry for the bad handwriting. I'll write a proper 3 right here. And that should be it really. So that's our number 1 point. That's where theta is, and then that's our other point. Really. So that's about it for that question. This is how we apply trig functions. That should be easy for you, but then this, if you done this before, but then again, there's a reason why you came here. All right, so why am I erasing? Why am I erasing? All right, so this one right now is where we need to apply the double angle identities, and this will take long, but no worries, it won't take long. I am here to help. All right, so um, let's take a look at this question here. So this question right here is saying, hold on, let me pull out green. So this question right here is saying sine of theta is equal to 3 over 5. All right, now find cosine theta, sine 2 theta, cos 2 theta, and then sine 2 theta. Right? So what do we do? Well, we do nothing. We just solve it. You know, you don't solve it, you don't pass, and you don't pass. The IB will see you in the next exam session. But shouldn't take us this long. I know I said it'll take this long, but if you follow what I'm about to do, we should do everything right. I am going to dedicate this whole section for the answers. So, alright, there should be an answer key right here. And, you know, uh, actually, I'm going to call this mark scheme, even though it's not. Alright, so let's go over through this one. So, you know, this one right here. So, remember this guy that I spent, I think, 5 minutes explaining in my horrible handwriting, and I do apologize for this. It's early in the morning, and I just came back from a calculus exam. So let's see. So cosine squared of x plus sine squared of x is equal to 1. So simply, I'm going to rearrange this whole equation. So that could be sine squared of x because we're finding cosine, right? I forgot to say that. I'm sorry. We're solving for cosine. So then cos squared of x plus sine squared of x is equal to 1. So sine squared x is simply equal to 1 minus cosine squared of x. So simply, I'm going to plug in. We know sine of x is equal to 3 over 5. So I'm going to do 3 over 5 squared is equal to 1 minus cos squared. So that becomes 9 over 25 is equal to 1 minus cosine x squared. So move that back, that becomes 9 minus 25 minus 1. Actually, yeah, there should have been, that's my mistake. I should actually reflect this, so yeah, I've done a mistake in the rearranging, so theoretically I'm going to reflect it, so cos squared of x is equal to 1 minus 9 over 25. So that should be, so cosine squared of x is simply equal to, yeah, so that should be, yeah, that should be 16 over 25. And then we can square this. We get rid of the squared, and then I'm just gonna go down here. I'm very sorry for the shitty handwriting. X is equal to 4 over 25. 4 over not, so 4 over 5. And that's it. So number 1, which is this one, is just 4 over 5. Alright. Let's move on to so we got it. I'm just putting what they equal to, and then I'll write them properly again. Alright, so we solved cosine theta. Now let's take a look. Sine 2 theta. What can we do? We can't just multiply it by 2. It's wrong. Let's see if we can. We're going to prove it. Prove if we can. But then looking at our data booklet, and I'll probably go back here. Hold on. We know that. How am I going to write this? We can apply 2 sine of theta, so sine 2 theta is going to equal to 2 sine of theta times cos of theta. Remember, we got it when we found this, and this is the beauty of IB. You need the first question, the first answer to get the second answer, and that's the beauty of IB. I believe you're gonna get a question where you're gonna have to use at least 2 identities at the same time. Like you're gonna have to apply one identity with the other so you can get the equation or something like that, and it's nice. And that's what we're trying to find right now. It's sine 2 theta, and we said, can we multiply this by 2 and we get the answer? No, because this identity tells us that the 2 times this is sine 2 theta, not the other way around. So let's go ahead and solve this. So that is going to be sine 2 theta is equal to 2 times 3 over 5. This is times, by the way. So this should equal to 6 over 5 times 4 over 5, which should equal to 6 times 4, that's 24, over 5 times 5, that's 25. So if we rearrange this, or now rearrange it 24 over 25, that is simply going to be, so looking back really, 24 over 25, can't we simplify that? We can't, so we just leave it like that. So we just think about it, can we simplify it or not? Again, you always need to think, can you simplify it? You can. If you can't, you really can't. What can you do? Like 1 over 1 can be simplified as 1, but if you need it as a fraction, okay, 2 over 2, 3 over 2, you just leave it like that. So let's take a look. So number 2 becomes 24 over 25. And then we can draw, you know, uh, just a line just to make sure that we don't collide the answers with each other. And then we can go ahead and erase this. Alright, let me erase this one and make it clear. That'll be 1 over, not 1 over, down. That's 1, and then this is 2. Now I gotta go to 3. Alright, now for 3, it's gonna be a simpler process because now I'm gonna use an identity from the booklet, which is cosine. Hold on, let me write this down. Cosine squared, or sorry, no, not squared. It's cosine 2 theta is equal to 1 minus 2 sine squared theta. And that should be it, really. That's how you apply it. This is an identity right here. Let me get rid of that line. Save space. And yeah, I should have wrote more out. That's fine. So I'm just gonna work off an equal here. Know that this is always gonna be equal to this, right? So 1 minus 2, and it's going to be 3 over 5. So that would be 1 minus, that would be 2, and that would be 9 over 25. That should be 1 over 18, and 1 minus 18 over 25. So that should be, realistically, that should be 17. That should be 17. Sorry, 7. So that should be 7 over 25, because we just subtract it, from how we do it. So that's 7 over 25, and then that's simply equal to cos 2 theta. That's what I'll have. Oh wait, okay, cos 2 theta. So that should be it, right? Yeah, that should be it. So we apply this, and we say 7 over 25. 4. 4, I'm gonna leave it for you guys to solve. I've done these 3 by myself, and I need you to solve it. And I'm gonna give you, let's see, this one you're gonna need, hold on, let me see, from my notebook, you're gonna need, yeah, you're gonna need about, I'm gonna give you 5 minutes to solve it. Usually you're gonna need less in the exam to get this, like 2 minutes to solve this, but then maybe even less, but 5 minutes, and we'll get back. All right, so right now we're done with the 5 minutes. Um, let's go ahead and let me clear this one away and solve it in front of you. All right, so we remember that we have a, you know, I believe it's called, I don't know what they call it in IB. Yeah, they call it identity of tan. So that's simply cosine squared. No, not cosine squared. Sorry, sine squared. Sine theta. Sorry, sine theta over cosine theta, and then we know that's 2, so that's going to be 2 here. It's going to be 2 here. It's going to be 2 here. So we found them here actually. We found them here, right? So see how you need this one right here to get to this one, to get to this one. Hold on. I swear, this is the last time working with the whiteboard here. But this one right here, this one right here, this one right here, and then this one right here. So simply, again, it's a fraction. I'm going to have a fraction over a fraction. How are we going to do this? So again, it's basically, 24 over 5 divided by 7 over 25. There's a way to rewrite it. So then we can just say tan squared theta is simply going to be 24 over 25 times 7 over 25. See what I did? I just took the reciprocal of this. I just took the reciprocal of that. I put it here. I'm going to erase that right now. And that should give us, if I'm right, um, that should be 25 over 7. So yeah, we do take the reciprocal. So why did I write it wrong like this? Alright, so these cancel out, so that becomes 24 over 7, and that becomes your final answer. Really our final answer. So I'm going to verify this on my notebook. It's on the second page and it says answers. So I'm going to use the red. So this is correct. 24 over 25. This is correct, and this is correct.